Okay, so we're going to do a quick review to help you guys review for your test on most of the basic concepts we're going to cover. Make sure you cover everything in the overall review, because I don't have time to cover everything that we did, but I did want to hit the core stuff. So the big thing here is we have two concepts: linear lines, exponential curve lines. One is the constant amount of change, one is the constant rate of change. Linear is addition, which also includes subtraction, the plus and negative basically. So any of those are always going to be additional increases or decreases. If they define it differently on the test, it'll be, you'll understand the similar words. And then exponential growth and decay, which is going to be multiplication. All right, so one is a rate of change and one is a set, a constant change. So there's two function rules you got to make sure you know. The first one is for a straight line, f of x equal mx plus b. All right, so which is the slope times whatever our units are, plus the constant, which is going to be the b. The example I have down below says cell phone is $25 and it's $10 per month for each gigabyte of data use, and that would be f of x equal 10x, $10 times the number of gigabytes of data, plus the $25 fixed fee. If you look at exponential, this is a growth. Right, you're paying out more money, so cell phone is $25, increased 20% for each gigabyte of use, compounded, should be gigabyte or data, but compounded, which means it's not 25 and 10%, 25 and 10%, it's 25 and 10%, which gives our new number, which is that number times 10%, and so on. So in this case, for this one, it would be f of x equals 25 times, so this is a times sign, not an x, 1.2 raised to the x power. So it all depends on which one you're doing. So for this problem, the y-intercept is 25, which is our constant, and the y-intercept is still 25. It's still exactly the same. The x's are the same, is it's independent, the independent variable, and it's the amount of data used, which represents each month will be one more unit of either $10 or 20% per gigabyte. Okay, the y-axis is going to be the cost per month, right? So, and that's going to be your dependent variable. So, in this unit, I should clarify, this unit rate is affected down here. This will just be 1, 2, 3, 4 month. It represents the data used per month. All right, so the gigabytes. So we know how much to charge for that month through. All right, so. Over here, same thing, it's going to be our cost. So I built a chart down here when we put these in. So at 0 is $25, at 1 is $35, $45, then I jump to 5, and then 10 is $125. When you look at the other side, it's 25, 30, 36, 43, 62, 154. And suddenly you see it growing. Remember, this 1.2 is really the 25, you got to include the 25 there. So when you multiply, if you go 25 times 0.2, you're going to get, whatever 2/10 of 25 is. If you multiply 25 times 1.25, you get 25 plus the additional percentage that's on there. So it's really one whole plus 0.2 more multiplied by 25, because you don't want that value to be smaller, it has to be bigger, so we have to include that one. If it is decay, it's going to be the opposite. Let's say this was going down for whatever reason. It would have been 25, 1 minus 0.2, or 25 times 0.8. It's going to reduce. Okay, so, and let's see, I want to come backwards because I realize this is the way this says. This is going to be so yeah, this is based on the number of data use. All right, so we get our values. If we put this in the calculator, all right, where these numbers are coming from is this. Now, this was pretty straightforward. So, like, take 10. It's 10 times 20, or 10 times 10 is 100 plus 25 is 125. For the other one, I'm going 25 times 1.2 xy 10. And I get 154.79, so in nearest penny because we're talking money. Okay, so the question I have at the bottom says can you find a number of gigs of data you have to use at 20% to be, so that plan costs more than the $10 a month plan. And we go through, and I'm going to kind of jump ahead. It turns out that it's 8. Now that is going to be 10 times 8 plus 25, which is 80 plus 25 equals 105. Over here, when we put in 8, so we go 25 times 1.2 xy 8, we find out that it's 107, and we'll call it 50. It's going to round up to the nearest penny. So we find out at 8 that's where you get past the break-even point. Now, taking that, we can take a graph here, and this graph is not going to be perfect or to scale, so I'm going to start at 25 on my graph. So this would be 35, 45, 55, 65, 85, 95, 105, 115, 125. Here it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's the amount of data that you're using in gigs. This is going to be the cost. All right, so if we take our two graphs, we take our first one at 25 and 0, 35, 45, and so on, we're going to find that it makes a nice straight line. Of course, I don't know how well I can draw a straight line, but here. Now, in this case, it starts at 0. It cannot be any less, but it's going to go on forever this way, but it stops. A lot of the ones you're going to test are going to continue this way, which would mean it's infinity to infinity. All right, but we should at least be able to get the gist. Now, when we take our other number set, it's starting at 25. The next one is going to 30. The next one was going to 36. The next one was going to 43. So at 3 was 43. Okay, then I jumped to 5. 5 went to 62. See, about there. Then I jumped to 10, and 10 went up to 1. Let's see. I'm off a line here. Would be 154. So what we end up with, this one is going to come in here and curve, and I didn't do all the points, but approximately like that. All right. So I'm looking at this. Actually, I got to resketch that because we said we already know in advance that this is about the breaking point. So this curve is actually here, and it's going to cut right about there. So I'm going to scratch that out because we already did it. We did our research through. Now, if I would have done every point, we wouldn't miss that. All right. So it brings me down here. So we have our two functions. So we're going to call this g of x. We're going to call this one f of x. All right. So here it wants to know the domain of f of x. Well, it starts at 0. So because that, and it's every unit. So we should have a curly bracket, 0, 1, 2, 3, dot, 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 which means it goes on forever. This other one's also going to start at 0, and it's also going to move 1, 2, 3, dot, dot, dot. All right, if the line went on forever and included every point, then we would put it in all real numbers, or in this case it could be all whole numbers, because it's always forward, it's always a whole number, but it doesn't include the partial. We're going to pay all or nothing. The range is going to be from 0, and in this case, because our units are going up and our bill is set, it's a little trickier to do, but in essence it potentially goes through all numbers, so we could put it in as 35, 45, 55, dot, dot, dot. That one's going to be set. This one's a little trickier because it's going to go by the multiples, but it's still going to be 25, then 30, and 36, and then dot, dot, dot's pretty good there. So, because it doesn't include all values because it's always at a set price for that data. So it's not a 1.5 gig, it's either 1 or 2 or 3 or 4. If it includes every numbers, then it's going to be all real numbers. It's going to go infinity to infinity. This one does not. All right, so the intercepts we already did. So we said, the x-intercepts is none for both because it never touches the line. The y-intercepts are both at 25, or 0, 25. Okay. The end behaviors, so of f of x is going to be as x approaches 0, because it stops at 0, then y, or as y approaches 25. And as x approaches infinity, because it goes on forever, as y approaches infinity. Okay, same thing here. It's going to be exactly the same in behavior in this case, these two different graphs. All right, so this is going to be the same. All right, so it says when is f of x greater than g of x? So f of x is greater than g of x. Well, it's going to be all of these values here. So it's probably going to be easiest to say when x is less than, and we looked at the cutout, right, it's less than 8. Okay, when is f of x less than? Well, we just look to see where it crosses over. We know the point right here is going to be our mark. So right at that 8-year mark, 7 point something years. So f of x then is going to be when x. Actually, let's go over here. Well, these are independent of the stuff on top. So when x, let's see, when g of x is greater than, so this really should be f of x. Make sure I have this right. So when g of x is greater, so when g of x, sorry, this is less than 8, not greater than. All right, g of x when it's greater than 8, 7 point whatever. All right. So again, look at the graph. It's going to graph in there. You should be able to visualize. See that if it crisscrosses twice, you have to account for both spaces. So less than and greater than, put in there. As long as you get that translated in a legible way, it will count. So this is the end of part 1.